Hi everyone, and welcome to the 10th video in the Weather Unlocked video series. This video will go over El Nino and La Nina and the type of weather that typically occurs during each pattern. Now, when you think of weather and climate, you might think of its variability, which can range from small-scale features, which might include things like wind gusts, localized thunderstorms, and tornadoes, to larger-scale features including fronts and storms, and even including multi-seasonal, year, decade, and multi-century timescales. Now, typically, these longer timescale events are associated with changes in the atmospheric circulations encompassing larger areas. And at times, these circulations can seem as if they're unrelated. However, you can get abnormal weather, temperature, and rainfall patterns worldwide as a result. Now, this leads us to ENSO, or El Nino Southern Oscillation. Now, when I say Southern Oscillation, that refers to the changes in air pressure at sea level in the southern Pacific Ocean between Tahiti and Darwin, Australia. So during El Nino conditions, the average air pressure is higher in Darwin than it is in Tahiti, and the sea surface temperature is warmer than normal in the eastern Pacific. Now, despite these two locations being 8,000 miles away, these occurrences are actually related. Now, when you have warmer than normal temperatures, you can also have cooler than normal temperatures, which leads us to La Nina, which has cooler than normal sea surface temperatures in the eastern Pacific and higher air pressure in Tahiti. So let's take a deeper look into what El Nino and La Nina all entail. But before we do that, let's look at what normal conditions look like. Now, normally the sea surface temperature is about 14 degrees Fahrenheit higher in the western Pacific than in the water just off of South America. This is because the trade winds are blowing from east to west along the equator. Now, when they do this, they're allowing that deep, cold, nutrient water to start upwelling or to come up towards the surface. The trade winds are also pushing water west, which piles higher in the western Pacific and makes a deep, warm layer that pushes the thermocline down in the west while it rises in the east. And when I say thermocline, that just refers to the transition zone from warmer water to the deeper, cooler water. So these are the normal conditions that you would expect to see. However, when the air pressure patterns in the South Pacific reverse direction, meaning the air pressure is higher in Darwin, Australia compared to Tahiti, the trade winds will actually start to get weaker and can even reverse directions. So when this happens, the normal flow of water away from South America decreases, which allows for more ocean water to pile up off South America. Now the thermocline also gets pushed deeper, which in turn decreases the upwelling of that deep, cold water. So when you have deeper thermocline and a less water transport, the sea surface temperature will begin to increase and become greater than normal in the eastern Pacific. And this is called El Nino and is the warm phase of ENSO. So when all of this occurs, the prevailing rain pattern is going to shift from the western Pacific, like what we saw in the normal conditions, to more towards the central Pacific. This picture is from December of 1997 and shows the change of the sea surface temperature from normal. So those bright red and orange colors show that the water was warmer than normal, which is typically what you would expect to see during El Nino. Now on the opposite end, we have La Nina, which occurs when the trade winds are blowing stronger than normal across the Pacific towards the west. Now when this happens, there's going to be very strong upwelling of that deep, cold water, which is going to allow for lower than normal sea surface temperatures, making this known as the cool phase of ENSO. Now since you have those stronger trade winds, they're going to push the prevailing rain pattern farther west and also pile up that warm surface water in the western Pacific. This image shows the sea surface temperature anomaly, or the difference from normal. So you can clearly see the cooler than normal temperatures in the Pacific, which is what we'd expect in a La Nina pattern. So how does all of this affect us? Well, as the position of the warmer water keeps shifting back and forth across the Pacific, depending on if it's El Nino or La Nina, that's going to affect where the greatest amount of evaporation will occur, which is going to impact the position of the jet stream, as you can see in this image. And the jet stream, as we learned in a previous video, is going to impact the troughs and ridges, which largely impacts the weather that we observe. So in the winter during El Nino, you'll typically see warmer weather in the northwestern and north central part of the U.S., with the Midwest seeing drier conditions, wetter weather in California and the southern U.S., and then colder weather in the south. Now you'll notice a big difference in the jet stream's position in the winter during La Nina, which leads to much different weather conditions across the states. You'll notice that it's much wetter in the northwest and midwest, and a lot colder in the northern and north central U.S. And then in the southern and some parts of the central US, it's drier and warmer. So you can see how much of an impact the global circulations and variations can have in the weather we observe across the world. So that concludes today's video on El Nino and La Nina. So stay tuned for future videos in the Weather Unlocked video series.